Meteorites hit Mars and create small craters like the one imaged here. Usually these new craters are spotted in lower resolution images from the context camera because the impact disturbs dust on the surface and creates a dark mark that's much bigger than the crater. This meteorite hit a dusty area and made a crater, but did something a little more special to the surrounding dust. We can see dozens of dark, dust-free streaks on slopes surrounding the crater. These slope streaks form when dust slumps downhill and happen naturally on a regular basis. In this case, though, the impact and explosion that made the crater seems to have set off many of these downhill slumps of dust simultaneously. This could have happened from the explosion's blast wave passing through the air or the shaking of the ground that it caused. This sweeping panorama shows the interior and rim of Gale crater, including much of the Curiosity rover's route during its first 5.5 years on Mars, and features up to about 85 kilometers away. Gale crater was formed about 3.5 to 4 billion years ago, when meteors frequently crashed into Mars. Signs of the impacts can still be seen today in the fractured rocks left behind at the crater. A huge lake once filled Gale crater in the past, which also provided a potentially habitable environment for life on Mars. Satellite data have also revealed ripple marks on the surface, superimposed upon each other in rock layers, indicating previous flow of water here. Curiosity data have revealed veins in the rocks indicative of past water flows below the ground, where sulfate minerals had been deposited. Study of the sediment deposits, mudstones and rocks have indicated a degree of erosion that points to a semi-arid past in which water existed here. Scientists believe that the surface water and groundwater at Gale crater interacted as hydrological system, with cycles of water moving between the layers. Such interaction would likely have sustained liquid water, even though the Martian climate was arid in the past. Mount Sharp stands about 5 kilometers high in the middle of Gale crater, which spans 154 kilometers in diameter. The foreground of this panorama shows portions of lower Mount Sharp. Study of various rock outcrops examined by Curiosity rover have shown that water deposited large amounts of sediments into Gale crater, which helped form the foundation of Mount Sharp. Degradation of the crater wall and rim probably supplied these sediments, which advanced inward from the wall, infilling both the crater and an internal lake basin to a thickness of at least 75 meters. This intracrater lake system probably existed intermittently for thousands to millions of years, implying a relatively wet climate that supplied moisture to the crater rim and transported sediment via streams into the lake basin. The deposits in Gale crater were then exhumed, probably by wind-driven erosion, creating Mount Sharp. The middle distance of the panorama shows the floor of Gale crater and most of the horizon formed by the crater's rim. On the horizon near the center of the panorama is a glimpse outside of Gale crater to a peak about 85 kilometers from the rover when the panorama was taken. In geology, a slump forms a mass of loosely consolidated material, or a rock layer moves a short distance down a slope. The movement is characterized by sliding along a concave upward or planar surface. Based on other high-rise images, this particular slump occurred between 9 March 2020 and 17 February 2021, corresponding to the relatively warm spring and summer of the southern hemisphere. This is among the largest active slumps documented on Mars, about 700 meters long. Causes of slumping on Earth include earthquake shocks, reduction of friction through wetting, freezing and thawing, undercutting such as from a stream, and loading of a slope. Based on the geomorphology of this region and other active slumps seen on Mars, it is suspected that loading of the slope via smaller-scale activity like gullies, recurring slope lineae and wind-blown deposits may have contributed to the slumping. Perhaps a Mars quake triggered the movement. On April 25, 2026, the Curiosity Mars rover drilled into a rock to collect sample. But the rock accidentally got stuck to the rover's drill, and the rover ended up pulling the entire rock out of the Martian surface. Nicknamed Atacama, the rock is estimated to be 1.5 feet in diameter at its base and 6 inches thick. It would weigh roughly 13 kilograms on Earth and about a third of that on Mars. Curiosity's drilling operations have previously cracked or separated layers of rock, but this was the first time a rock stayed attached to the drill sleeve itself. NASA engineers spent several days repositioning the arm and vibrating the drill to try and get the rock loose, finally detaching the rock on May 1st. Taken with Mastcam, this observation shows the rock during the drilling and a patch of exposed regolith following the removal of the rock.